On the basis of this theorem, means J, if a line is drawn parallel to one side of a triangle, it will intersect other two sides in the same ratio. On the basis of this theorem, we will prove this theorem. We will prove this sum. This sum is given. ABC is a triangle. DE line is parallel to BC. We want to prove AD by AB is equal to AE by AC. We want to prove this thing. How we can prove it? So it's very simple. Some simple mathematics involved in this. Alright students. So according to the theorem, we know that, any student can tell me, according to the theorem we have learned, if DE is parallel to BC, then what are the two ratios which are equal? Can any student tell me? Online student, in this triangle, what we can say? Any student? So these ratios are equal. So we can say AD by DB is equal to AE by EC. This we have already proven yesterday. Okay. Now you see, we want to prove where AB is there. Okay. So AB means, we can make a hint that AB is the sum of AD plus DB. Am I right? So if I add 1 in this, it will be AD plus DB, that will become AB. But here will be DB only. But here there is no DB. Here there is AD. So what I will do? I will reverse these two. So I will take reciprocal. What I will get? DB by AD is equal to EC by AE. What is this step, students? See, 1 by 2 is equal to, let's say, 10 by 20. Then if you do reciprocal, that will also be correct. 2 by 1 will be equal to 20 by 10. 2 is equal to 2. Correct? So this we have proven. Add 1 on both sides. So what will you get? EC by AE DB by AD plus 1. If you add 1 on both sides, you will get DB plus AD, DB plus AD. DB plus AD is AB by AD is equal to, yes students, what will be on this side? Any student online? Here what will I get? EC plus AE divided by AE. So that will be EC plus AE. EC plus AE is AC. AC by AE. So from here I am getting, now do again reciprocal. AD by AB is equal to reciprocal of this AE by AC. We wanted to prove this, we have already proved. Thank you. Alright students, now we are doing second sum. In the second sum we are having a trapezium A, B, C, D. You know students, what is a trapezium? Trapezium means a polygon with how many sides? 4 sides. 2 sides AB and CD are parallel. 2 sides are parallel and 2 sides are non-parallel. Right? So a rectangle is not a trapezium, because in rectangle both the pair of sides are parallel. Parallelogram is also not trapezium. Right? Because 2 sides should be non-parallel. So here AD and BC, 2 sides are non-parallel. Now my fingers are parallel, these are non-parallel. These are non-parallel. Parallel lines meet at infinity. Non-parallel lines, they meet at some distance. Remember. So trapezium, the question is, PQ line is parallel to AB. PQ line is parallel to AB and P is on side AD, Q is on the side BC. We want to prove what? AP, this side by PD is equal equal to this side by this side, BQ by QC. We want to prove this. So this kind of ratio we know in triangle. We don't know how to prove this ratio in, what is this? Yes, trapeze. We don't know. We will prove today. So we will prove it in two ways. In two ways we will prove it. How? Number one, we will, very easy way. This is BC. We will do some construction. What is the construction? We will draw a line parallel to BC. Let's say AL. This is a construction. Construction means asikita. We are doing something which is not given. So, what is the construction? Draw AL, tell me students, parallel to, tell me, draw AL parallel to BC. Very good. Okay. So, when AL is parallel to BC, can any student tell me? You see, it is given that AB is parallel to PQ. So from this, can we say AB is parallel to PQ? Okay, no. AB is parallel to PQ. This we are understanding. How? It is given AB is parallel to DC, because AB and DC are two parallel sides of trapezium. This is already given. So these two lines are parallel, right? And it is given this line is parallel to one of the side, either AB or DC. So if two lines are parallel and one side is parallel to one side, that side will also be parallel to other side. Remember that. This is very interesting. If these two sides are parallel, suppose this side is parallel to this side, automatically this side is parallel to this side also. Got it? This is very important, right? So AB is parallel to DC. This is given. From this we will get AB is parallel to PQ also, right? Because it is given PQ is parallel to one side, AB or DC. Let's say PQ is parallel to DC, so PQ will also be parallel to AB. Am I right, students? Okay. Now, can anyone tell me what is the shape of this polygon ALCB? What is this polygon? Can anyone tell me? Wait. You students, please keep quiet. You are late comers. Yes, any student? What is this shape? Please tell me. Is it a rectangle? No. It's a parallelogram. It's a parallelogram. So this is a parallelogram. Alright, because AL is parallel to BC and AB is parallel to LC. Okay, fine. So if that is the case, let us say this point is O, this point. So obviously we know that OQ is also parallel to OQ is also parallel to LC, because OQ is part of PQ and LC is part of DC. So both are parallel. See, if these two lines are parallel, then these two parts, this part and this part, will also be parallel. Remember that. Alright. So we have done that. Okay. So ALCD is a parallelogram. Am I right, students? Okay. Now, okay, fine. Now you talk about triangle ADL. Which triangle? Triangle ADL. In this triangle, PO is parallel to DL. Do you agree? Why? Because PQ is parallel to DC. So PO is the part of PQ. DL is the part of, don't speak, DC. Correct. So we can say PO is parallel to DL. Am I right? So now we have learned a theorem. In a triangle, if one line is parallel to one side and if this line is intersecting other two sides in the same ratio. That means, can you tell me what I will get, which ratio? Can you tell me, students? Which ratio is equal? This is AP and this is PD. This is AO and this is OL. Yes, can you tell which ratio will be equal? AP by PD will be equal to AO by OL. No, the one correct. AO by OL. Okay. Now, students, you see. In this parallelogram AOQB, AO is equal to BQ. Am I right? AO is equal to BQ. How? Opposite sides of parallelogram are equal. So AO is equal to BQ and AB is equal to OQ. So we can say AO is equal to BQ and OL. Any student? OL is equal to QC. Alright, students, we have already proven what was asked. AP by PD is equal to BQ by QC. Right? This is simple way. Now I will also do how the book has done. Alright, students, now I will prove this in other way as per your book. So in your book it's given join A and C. Got it? Join A and C. When you join A and C, you talk about the triangle A, this is D, ADC. In this triangle, first you already do that PQ is parallel to DC. So PQ will also be parallel to AB. That you already do. Okay. So if PQ is parallel to DC and PQ is also parallel to AB, so PO is also parallel to PO is part of PQ. PO will also be parallel to, come on students, PO will be parallel to DC. Okay. So PO is parallel to DC. So we can say what is the ratio? Which ratios are equal? Please speak, online students. In a triangle, when this line is touching two sides at P and O, and when this line is parallel to one side, other two sides are divided in the same ratio. So what is the ratio which is equal? Please tell me. Students, please tell me. So we can say AP by, yes, AP by PD is equal to, yes students, what is the other side? By OC. Correct. AO by OC. This is first equation. Now see this triangle. Now see triangle ABC. In this triangle, OQ is parallel to AB. OQ is parallel to AB. Now can you tell me the ratio? OQ is intersecting two sides, AC at O, BC at Q. This can you tell the ratio? Loudly, can you tell? In ACB, what is the ratio which is equal? AO by OC. AO by OC. Okay. AO by OC is equal to BQ by QC. BQ by QC. This is second equation. See that, students? AP by PD is equal to AO by OC. Here AO by OC is equal to BQ by QC. So from first and second equation, see, right side of one equation is equal to left side of one equation. So left side of one equation will be equal to right side of other equation. So we got AP by PD is equal to BQ by QC. This we wanted to prove. So there are two methods to prove this. Thank you. Yes, students, now come very interesting part. Now we are going to do experimental validation of theorem 6.1. We want to do experiment. Let's go outside the books and enjoy for 1 minute. Okay. First let us understand what is theorem 6.1. Very interesting theorem, students. Okay. The theorem says if this is a triangle, let's say the triangle is ABC. If one side is parallel to, if one line, let's say this line PQ is parallel to one side of triangle, in this case PQ is parallel to BC, then this line will divide other two sides in the same ratio. This is the theorem. That means AP by this distance by this distance. PB is equal to AQ by QC. This is the theorem. We want to experimentally check this theorem. See how will you do. You can take different measurement also, students, and I encourage you to do different experiments and see, you will enjoy it. So I am going to draw a triangle. Okay, I am going to draw a triangle. Alright. Here I will draw, I will take 20 centimeter this distance, and this distance 20 centimeter, and I will take 5 centimeter more. This is 5 centimeter, this is 20 centimeter. Experimental validation, we are doing experiment. Now students, can you tell me, if this side is AB and this point is, let us say, P, what is the ratio of AP by PB? Wait, online students, can you tell me what is the ratio? AP by PB. What is the ratio? The ratio is 20 by 5, that is equal to 4 by 1. Am I right, students? The ratio is 4 by 1. Same ratio I will create on the other side. Any angle. You can take this any angle. This angle, this angle, this angle. Any angle you can take. Okay? So let me take this angle, but I will maintain same ratio 4:1. How? I will do 4:1. Okay, I will take 8 centimeter here, 8 centimeter. Now, please tell me how much centimeter I should take here so that this ratio also becomes 4 by 1. Can anyone tell me? This is 8 centimeter. How much distance I should take so that this ratio and this ratio becomes same? Any student? So 20 by 5 is 4 by 1, and 8 divided by 2 is equal to 4 by 1. Am I right? Students, am I right?
Yes, sir.
Good. So I will take the distance how much? 2 centimeter. I will take 2 centimeter. This is 2 centimeter, 8 centimeter. Now I will join these. I will join this. Yeah. So I am getting a triangle ABC. Okay. Now P and Q. These are the points at which AB side is divided in the ratio 1 by 4. At point Q, AC side is divided in the ratio 4 is, I'm sorry. Yeah, this is AP by PB is 4 is to 1. And AQ by QC is also 4 is to 1. Sorry for the small mistake. Now, what is experimental validation? If I join these 2 points, this line will be, can any student say? If I join these 2 points P and Q, this line will be, according to the theorem, what? Any student?
Parallel.
This student? No. We don't know the length of this line. The theorem is not talking about length of this line. The theorem is not talking about length of this line. The theorem is saying if PQ is parallel to this ratio is same. We have done reverse. We have already taken this ratio same. So what will be proven? This line PQ should be parallel to
BC.
Correct. Beautiful. This is the reverse of this term. So let us try. I am going to join this. I am going to join this. Now you see, students, exactly you can see. You are so happy. PQ is parallel to BC. That is experimental validation. This is one way to check the theorem experimentally. There is another way. First we have taken what? Ratio same. This line is parallel. Now we will take, any student? First we have taken ratio same, line is parallel. Now we will take one line parallel. The ratio will be same. We will check it. Okay. So here I will draw this. I've drawn this line. Okay, I've just drawn this line. Okay. Then I will draw this line is AB, which is 20 centimeter. Now I will join one more line, any angle. You can take any angle you want, students. You should do this experiment yourself. Yes. Okay, fine. I've taken it as 12 centimeter. Now I will join this. Okay. Now this is a triangle ABC. Alright, students. Now I will draw one line parallel. Okay, so I will draw one line parallel to this. Here this is like this. I will not draw like this. I will not draw. No. This, and I will take this. Yes, I have drawn the line parallel. Now according to the theorem, the ratio should be same. Now let's say this line is PQ. Now I will measure AP and PB. Now AP is 16 and PB is 4. Let me measure this. Okay, this is coming as 13 and this is coming as 3 point something. I can't measure correctly. 3.67 I think. 3.6 or 3.7. I can't measure exactly. Okay, now I will find the ratio. I will find the ratio. What is the ratio of this? 16 by 4, that is equal to 4 by 1. What is this ratio? 13 by 3 point, let us say this is 3.6 or 5. I can't measure exactly. Okay, so maybe this is 3.4 or this is 3.3. I can't measure exactly. This ratio is also approximately 4:1. So both these ratios are coming to be same. So you should do similar experiment and please WhatsApp me. Thank you very much.